Yeah, so this I'll just cover off on northern New South Wales and the Central West in this particular project, which goes from right across northern New South Wales and into Queensland, and then Beck will cover off on some results up in Queensland. Just to acknowledge, Leigh Jenkins is involved in this project as well, working out of Trangie, looking after the Central West area. I thought I'd just start by just a bit of a recap on the seasonal conditions for last year, which had a huge impact on the outcome of some of the experimentation. It was quite a mixed season. Just on chickpeas themselves, in their vegetative stage, they're pretty robust. They can handle some extreme cold weather conditions, but as soon as flowers initiate and things start happening, they become extremely sensitive to cold weather events. The point I'm trying to get at here is that just about at all sites up in the north, relative to when the crops were actually around that 50% flower, we've had, as you can see here at Edgeroy and Narrabri, that we've had some fairly major frosting events that have led to flower abortion. Now, not all areas in the north and central west were affected as badly as that, but certainly we did suffer from some extreme cold weather events that knocked flowers off. Now, the crops can come back and keep flowering, but it can have a major impact on potential yield. And if that wasn't bad enough, everyone will be familiar with what happened last year. We moved into a terminal drought situation. So you can see here, for example, up around Moree, that was the June to October rainfall compared to the long-term average for that area. And you can see that most of these northern locations received substantially less rain over the main growing period. We were obviously a little bit better off down on Liverpool Plains, but most sites received substantially less rainfall. And that was borne out more in terms of, September, October at the business end of the season when these crops were trying to fill. And you can see out at Rowena, at Spring Plains, it was pretty disastrous. So we've had frosting events to knock flower number around. We've had terminal drought, which has knocked out pods and seed numbers. So it was a tough season, but some of those crops did better than what I anticipated they were going to do. So what I'll do is I'll just cover off on some nutrient work, a bit of plant density, row spacing, and then just show you some varietal comparisons with just one of the new numbered lines that's coming through that may be of interest. Now, this is the second year that I've run these nutrient omission trials across northern and central New South Wales, across this range of sites. What we're trying to do here is just have a look as to whether there is any macro or micronutrient that might be limiting yield in chickpeas. The way we go about these is the P and N are applied at sowing at sort of starter rates, and then the balance of these macro and micros are put on as a foliar spray at or near flowering in a chelated form. So we're not trying to get away from any confounding that's come with using different sorts of products. So it was important to do that. And then we just put them on with a little spray rig on our small plots. Now what I've done here is I've just stripped out the zero nutrient treatments are the red bars, and the blue bars are the all nutrient treatments at this range of sites. And you can see that the majority of them, we actually ended up with nothing. We had no significant outcome. The only major outcome we had two sites, one of which is not located here, that's Trangie, but we did pick up a small yield advantage at Spring Ridge on a vertisol where we put all of our nutrients on. And that equates to about a 5% yield gain. There did appear to be a bit of a trend here in terms of we were starting to cook these crops, and that actually came out at Coonamble. This was really severely droughted, and we've actually suppressed yield, mainly through a reduction in seed number. The other thing too is we were trying to put these on at around first flowering, but because of the mild conditions, the rate of development of these crops, basically they just shot ahead of us. So some of these sprays were actually a little bit later. We were into flowering when some of these actually went on. Now, just what I wanted to do here was just have a look at some of the harvest indexes that occurred across these sites in 2014. And some crops have done substantially better than others. Just up at North Star, so this is just the zero nutrient treatments, but that particular crop there was on the back of was out of a cotton. So cotton followed by a very late sown barley crop, which essentially failed, but they were trying to get a bit of residue back into the system, and it was sitting on about 300 kilos of N and very little water. But the way that season panned out, this is Hattrick, by the way, across these sites. It still managed to perform quite well in a season that we had last year in terms of 44% harvest index. Moree, you see the yields halved. It's still done quite well given the circumstances, and in that particular case, we were basically sitting on no water in the profile. So it's adjusted its biomass early on through lack of water, and it did receive a couple of late rainfall events, which again led to this. That's not a bad outcome in terms of petitioning. Here, that's essentially due to frosting. It was probably the worst frosted site we had across the north. The crop was looking fantastic, but it got belted quite severely. Spring Ridge down on the plains performed well, and here our two western sites, which this is a fairly common outcome, unfortunately, where crops like this crop here at Spring Plains look pretty good. Talking to Matty Gardner, who we were in the same paddock doing experiments, it was sitting on around about 100 mils of soil stored water. And what's clearly happened here is it's put on its biomass, it's then been hit with some frosting, but it's a terminal drought effect. So it just didn't have the ability to convert that biomass into grain. And the amount of aborted grain that we're picking up at these sites is quite substantial. So it's a common problem out there, something that we need to try and get our head around. That's actually the Edgeroy crop that I talked about that got frosted. So I'll move on quickly now. I'll just have a quick look at some density and row spacing work that we've been working on. Here's some density outcomes for 2014. These are trials they're all at half-metre row spacings, by the way. There's 4 varieties in these trials. We found no significant difference in varieties or interaction at any of the sites. So I'm just looking at the main effects here on density. But basically the story goes like this, that in low yield potential areas and sites, we get this really strong plateau at around about this 15 to 20 plants per square metre, and it just flattens out. In fact, in Coonamble in the previous year, this actually tipped down. So in low yield potential areas, it's starting to tip over, and we're advocating that people should be looking at around that 15 to 20 plants per square metre. Now, as you move into more favourable and high yield potential environments, it's fairly critical that you start pushing your plant densities up. And up here at North Star and Spring Ridge, we're advocating that people should not be below 30 plants per square metre. And you can see here at North Star, when we put it out, we actually tipped it over at 45 plants in last season. So this is holding. It's been holding over the last couple of years for these environments, and we're pretty confident in terms of advising people about appropriate densities within their environment. Just another point, we've talked about virus already. Some of this work was done to look at the impact of virus through plant density, and something that came out that was very strong is that if you have virus and you're in areas where you can get virus, the incidence of virus goes up substantially when you drop off your plant density. So you really need to ensure that you've got solid, high density stands, and that seems to be a deterrent to the aphids that are coming in and passing the virus onto the crop. Now, just quickly on some row spacing work, just on a comparator here. So what we've done is we duplicated These are fairly large trials. I've only got the main effective row spacing, but these are variety by density, of which we ran 15, 30 and 45 plants per square metre across a range of row spacings from 20, 40, 80, right out to 1.2 metres. And what I've done here is I've just pulled out 2 years, a high rainfall year, high yield potential, 350 mils, which is the blue line at the top, and last year, where we received around about 165 mils in crop rain. And basically what happened is in last year, we got a fairly flat response across all cultivars, so there was no varietal. The varieties Kyabra and Hat-Trick and 1007, which I'll talk about later, all behave the same in terms of their interaction with density and row spacing. So they didn't behave differently at all. But it was basically flat out to 0.8 of a metre. So we weren't getting yield loss out to 0.8 of a metre in a low yield potential year. But in the wetter year, where we've run this, we did get a yield advantage where we were back at 40 centimetres. So we're comfortable with the way things are going. Like if you look at the western sites, most guys are on wider rows. It fits in really well with their system. It suits the crop and it helps them in terms of their soil water extraction and patterns. But if you're in a higher yield environment, places like around the Golden Triangle and certainly down on Liverpool Plains and further south where seasons are longer, probably a bit cooler, we're advocating that you should be coming back to around about those 40 centimetre row spacings. Otherwise you'll be losing yield. But these are decisions, there's compromises to be made in row spacing within the system. Now just quickly, I'll just run across some of the varieties that we looked at last year. So this, we've got Boundary 1007, which is a line that we're playing around with at the moment. This is Hat-Trick and Kyabra. Just on 1007, I think it's out of a Yorker background and it's got improved ASCO and some Phytophthora resistance as well. So it's a variety that I think 200 kilos has gone forward for seed increase out of for this year, which is why we wanted to have a look at it. Now one thing I did point out last time was the performance of Hat-Trick. It hasn't performed as well as what we've seen in the past. Rob Blong seemed to suggest, and I tend to agree with him, that it's probably less tolerant in terms of cold tolerance compared to some of these other varieties. So I think where we've got those frosting events, it's probably suffered worse than the other varieties themselves. You can see that Kyabra is always a fairly strong performer for us across a whole range of environments. So it has some very good attributes. One thing I can tell you is that just with some balance work that we did with a whole range of varieties, when we looked at the shoot to root ratios with some of these varieties as seedlings, Kyabra had the highest. So its ability to actually pump out roots relative to its tops is quite high, which could be an advantage, especially in some of these dry years, and why it's doing so well in the western areas. Now, seed size, so this is 100 seed weight of the same varieties. The thing that's encouraging here is that 1007 is a big seeded variety, bigger, and in most cases it's around the seed size of Kyabra, but it's holding across a range of environments last year. This was a pretty hard water limited site here, but it still maintained its seed size, which is a great asset. And just the last thing, back to harvest index, which is an issue where we'll be putting a lot more effort into trying to resolve this. You can see here, this was the worst site, Coonamble. The varieties are fairly stable in terms of their HIs at that site. That's pretty woeful at 27 to 25%. But the encouraging thing is that when these varieties are given an opportunity under a higher yielding site, we're looking at some fairly decent harvest indices with this new variety relative to Kyabra, which has always been a good performer. It's probably been the best performer out of our suite of varieties that we've run and had a look at over the last couple of years. So just to finish up quickly here, just on the nutrition work, again, we've only been out this 2 years. We're going to go at it again this year and do some additional work. But to date, of the 16 experimental sites, we've had 4 of them that have shown yield responses to applied phosphorus. So that's that's the only nutrient that we've picked up in terms of nutritional responses across these sites. We have observed some visual responses to applied phosphorus, and you see this a lot. You see it in cereals. It's fairly common, but it grows out of it. One thought that I put in was access to deep pea, and then John Thompson pointed out the mycorrhizal colonisation of chickpea and its ability to extract pea once that happens later in the season, which is probably another explanation for what's happening here. But we've picked up no micros in the last 2 seasons. Just on that, what we'll be doing this year, I think there's a time of application issue, so we'll be looking at moving time of application of the chelates forward. So we'll be looking at early application versus first flower and split rates as well to see whether we can pick up any effect by going earlier. And hopefully it's not as tough a year. Now we're comfortable with some of these rule of thumbs now with our density advice, where under high yield potential, we're fairly confident across the suite of varieties, and they all seem to be behaving the same, that you should be aiming for that 30 plants per square metre, especially in areas where you have virus. In the lower yield potential areas, in some of the western areas, back around that 15 to 20 plants per square metre, especially where you're on wider rows at 75 and 80 centimetre rows, you're not suffering any yield penalty. So trying to maintain a nice dense row stand is the objective there. If you are sowing later than ideal, work by Jeremy Wish and a little bit of work that I did a couple of years ago showed that you really need to probably push your target density up if you're chasing a late sown crop. It's mainly due to issues related to potentially poor establishment, and you've just got less time to put nodes on and flowers. And just the last point on row spacing, again, we're fairly comfortable with these rule of thumb recommendations now, that in high yield potential areas, we'd be advocating people back around that 40 centimetre row spacing, because there is a potential for yield loss. But in lower yield potential areas, we just seem to be finding that response to row spacing is reasonably flat. And most of the newer varieties seem to be far more plastic. I mean, all that original work done by Felton, which established the row spacing principles that we're still operating under now, were done with an old variety called Amethyst. And when I did some comparative trial work with Amethyst, it basically showed a linear decline as row spacing went up, especially under high rainfall in high yield potential areas. So it's encouraging to see that Hattrick, for example, is far more adaptable across row spacing than some of the older varieties. If you're sowing early, please don't go too early. It doesn't matter what you do, you'll run into that biomass issue. These things will just keep piling it on. They'll use water, and you could run into grief at the end of the season. But sowing on wider rows to restrict soil water extraction and reduce early biomass is one strategy that you could employ for earlier sowings. And I'll leave it there, Mr. Chairman, and Beck will be up.
Righto, thanks so much for that. It's always great to follow Andrew, actually, because we've got a good consistent message across Queensland and New South Wales. A lot of the data that I'll be presenting is definitely very well aligned with what the New South Wales team have found. It's really good to have these sort of projects working across the whole northern region. So just a little bit of background quickly as I can. I'm part of the Queensland side of the National Pulse Agronomy Initiative, so I'm based here in Goondiwindi. I've got Kerry McKenzie, also part of the team based up on the Downs. We've got Doug Sands up in CQ, and then we've also got a team at Kingaroy with RCN Rachaputi and a tech team. So we cover quite a good area there in Queensland. We're looking at summer and winter pulse as well as part of this project. So winter being chickpea, faba, and then summer soy and mung, and then we are also looking at a small component of peanuts as well. Today I'm going to be looking at the trials that we've done in 2014 for chickpea and Fababean. So we'll run through some plant population and some row spacing, and also some time of sowing for both of those. We'll start off briefly with the chickpea trials. So we had 4 trial sites across the southern and northern downs. I'll focus on the downs and north and south. I won't be going into CQ for the information today. So we'll be looking at Garrah and Billabilla, and then also Warra and Dalby. Now we had these ones we had a split plot trial designs, 3 reps, 3 cultivars. So we were looking at PBA boundary, PBA hat trick, and the pre-release sizer 0912. We looked at 3 different row spacings, 25, 50 and 100, and then 4 densities of 10, 20, 30 and 40 plants per square metre. So this initial slide is looking at the results from yield and from Billabilla and Garrah. Now what we're looking at here is the green lines are Billabilla and the blue lines are Garrah. Now Billabilla we did actually achieve some varietal differences, however it was boundary that got the highest yields at the lower densities. At Garrah you can see the lines being quite closely together, we did not get a varietal difference. Looking, however, at the row spacing, so we have 25 centimetres, 50 centimetres and 100 centimetres, you can see there are significant differences, and anything over that 50 centimetres, you really start to slide off if you start going wider than that. So you will be looking at a yield penalty over 50 centimetres. A little bit of background on both of these sites. Billabilla, we had good planting moisture, planted on the 4th of June and harvested 20th of October. We had a total of 82 mils of in-crop rain and good planting moisture. As you know, it was a pretty tough season and we did have a very hot finish, but no issues with frost last year. Garrah, on the other side of the coin, we had a total of 93 mils of in-crop rain. However, we did start off with a very, very low planting moisture at Garrah. We virtually almost did not get that one out of the ground. We were very fortuitous to get this rainfall event not long after planting, which actually saved our butts. I think it was actually all a bit of good management rather than luck, actually. So those 2 sites have come off quite well, but again, in a very tough season. So looking at Warra and Dalby, the 2 other sites, now there was definitely no difference found in cultivars at this particular site, so I've left that off the graph as opposed to the first one. However, you can also see at this site that reduction from 25 through 50 and down to a metre. So we're certainly looking at the same differences there. CISA 912 though did have marginally higher yields at these 2 sites. Same story again with the weather, again a bit of a tough season. Both of these 2 particular sites had good planting moisture though. Again, not much in the way of useful rainfall throughout the season. Dalby had 2 events which would have been a little bit more useful. These ones here around that flowering period. But otherwise it was pretty tough, as you know. We've also looked at a little bit of water use efficiency as part of these trials. Now, we have only done it on 2 sites in this preliminary year, which was last year. However, we will be looking at expanding that across the next few seasons. As you can see on this graph, we've got Warra and Billabilla. Warra and Billabilla. Now, each of those bars is represented 25 centimetres being the blue and a metre being the red. The average for chickpeas that you'd be looking to find is around that 8 kilograms of yield per millimetre of moisture. The grand mean for Warra was 8.3 and Billabilla 10.7. So we are actually looking at some reasonable water use efficiencies. And you can see that across the 25 centimetre rows, we are getting a much greater water use efficiency at both sites. So we will be looking at that again moving forward. Just looking briefly at plant population, same sites we looked at, all on a 50 centimetre row spacing. Populations of 10, 20 and 30, 10, 20, 30 and 40 plants per square metre. 3 cultivars, the hat trick, boundary and sizer again. So this graph, although it looks a little bit busy, I want you to focus mainly on this line here, which is the trend line. You can see most of the sites seem to be moving up from the 10 plants per square metre and then seem to plateau out across 20, 30 and 40, which is pretty much around about the same thing as what Andrew has explained for targeting the higher yields in New South Wales. So we'd be comfortable, as with New South Wales, to say that anything 10 plants per square metre, you're really looking at a yield penalty at that level. However, around that 20 to 40, you're looking at around about the same. but you're not really going to get a significant yield increase at 40. So we'd be comfortable at around about that 30 plants per square metre, as New South Wales was as well. So jumping across to faba beans, we had 2 sites, Garra and Warra, looked at row spacing and cultivar. So again, the same row spacings, and the cultivars being Cairo, which was actually what was grown in the rest of the paddock. All of our trials, especially down in this southern area, are all actually on-farm trials. They're all small plot trials, but we don't actually have a research station. So we are relying on the cooperation of growers to help us, which is really wonderful, and I'd like to thank them for that. So Cairo was grown in the rest of the paddock down at Garra. We also used water and the pre-release X220D variety. We also had a time of sowing trial up at Dalby, and so I must thank Glenn Milne for his assistance with this one. We had 3 dates, late April, which is considered to be around about average for down in this part of the world, and then we had a mid-May and an early June, all on a 33 centimetre row spacing and at a targeted 25 plants per square metre. Now looking at this graph, we've got Garra being the blue line and Warra being the red line. We did get some quite high yields down at Garra, however we were planning on a full profile, and we did get lots of good sunlight, good radiation throughout the season, and we definitely 100% drained that profile. Warra, we still had good yields, however we did get a little bit of insect and disease pressure early on in the season. But again, same with chickpeas, you can see that the 25 centimetres is certainly, the narrower rows is providing a good, the best opportunity for yield, sliding across the 50 and then again down to the 1 metre. One thing to remember about this X220D variety, which is coming out in the next couple of seasons, is it is a much larger seed. So based on the seed weights that we've collected this year, X220D is around about 25% larger than the counterparts Cairo and Water. So keeping this in mind, we're actually going to be looking at some more density trials with faba beans this year coming, because we'd like to know if we can actually sow slightly lower density given that higher seed weight, high seed size. So watch this space for that information. The Dalby time of sowing trial. Here we can see the 3 dates that we've looked at, the 23rd of April, the 19th of May and the 9th of June. Now again, this was done on PBA water at a 33 centimetres at a targeted 25 plants per square metre, which is currently the commercial recommendation. Now, as you can see, across these 3 dates, there's a linear reduction basically from that first date going through to June. So at this stage, based on this 1 year of data, we'd be looking at earlier is best at this point for this particular season. However, we are going ahead to look at this more this year, and we will be starting mid-March with our dates this year. We will have 4 planting dates. We're doing this trial in Goondiwindi as well as up on the Downs again, starting mid-March and then fortnightly for 4 dates post that. So it'll be interesting to see whether if we're pulling the dates back a little bit sooner, whether we'll get the same result. So in summary, narrower rows, 25 and in most cases 50 is certainly significantly higher yields for both chickpeas and faba beans. This result was also achieved in the previous year of trials in the chickpeas. The pre-release faba bean variety X220D yielded 20% greater in the 25 and 50 centimetre treatments over water and Cairo. However, we're looking to investigate that as discussed due to the seed size. Across the sites where water use efficiency was measured this year, narrower rows consistently produced higher water use efficiency. And earlier time of sowing dates showed to be achieving higher yields in faba bean, but more investigation will be required. Another point that I'd like to mention is we had the discussion with Hugh Breyer this morning in this morning's session that 25 centimetres, although it is actually getting the highest yields, there are some trade-offs. Looking at insect pressures and things like that, using beat sheets are obviously much harder on those narrower rows, so there is going to be some sort of trade-off there. However, we are actually going to be doing some collaborative work with Hugh and Melina this year, looking at some sampling across those narrower rows so that we can try and quantify that a little bit better.